And action.
Action.
Take one. Milk's here.
MoNaCo 2.
Unit 9. Video 5.
Page 15. Thing.
Now we're going to talk. Oh, this is like a review video.
Oh, yeah.
We did heat a reaction already.
And not only did we heat a reaction in the last video, but we did it in the last 2 units ago.
Seriously.
Bigger matter.
Yeah, with this whole positive, negative thing. So
right.
We'll review it real quick and we'll be on our way.
Let's do it quick. Cool. So remember, for table I, delta H values are given for each reaction, and it's over there on the right-hand column.
Yep. There is a delta H value there.
Kilojoules per mole.
Right. These values are, if they're negative, it's exothermic, and if it's positive, it's endothermic.
Right.
Got it?
So taking that new information or that old information and what we had seen in the potential energy diagrams,
Now we can relate them.
we could take any one of them and make a potential energy diagram for it because we know what the delta H
Right.
is.
And here's another review. We did this already, actually.
Mm-hmm.
So if I double the reaction, I'm going to
Double the amount of heat involved.
Right,
Enthalpy.
Did I get out? Did I have to put in or get out?
Double
Right.
it.
Double it. If I half it,
Half the H value. Delta H
then
value.
I take that number and I.
And when we're saying we're doubling and halving, we're looking at the mole coefficients
Right.
and relating them to what the table I is saying. If
Sure.
my mole coefficient in my problem says 4, and for the same reaction on table I it says 2,
You doubled it.
the question has doubled it, so you got to double the heat.
There you go.
And if my problem is saying 1 mole,
And table
T,
I says.
I says 2,
you
we've
took-
halved the
There you go.
reaction. So
Right.
just a clarity on that.
Yeah, and it's a great one, and it's very much an analogy if I want to make 2 dozen cookies versus 1 with the recipe calls.
Mhm.
I
Now,
double everything.
If we're going to run that reaction that's shown on table I in reverse,
Which-
which is possible,
And you know that our test that we deal with is going to ask you one of these things.
you got to flip the sign on the delta H value because you've flipped the potential energy diagram.
Right, and you'll see when we draw those things, if I just go backwards on the one I already drew,
It is the new one.
it's the new one. It's the flipped version.
Right.
If I started out high and went low, and then I go reverse, well, then I just started out low and went high.
That's it.
So I got to change the sign. So let's do some.
A couple examples. We got a reference table I around
You
this?
got it right there.
No, I don't.
This is a chemistry classroom. There's always,
so shot right now.
dude. There's always reference tables
I,
all over the place.
J, I comes after H and before J.
All right,
so
so
here's the reaction.
I see nitrogen gas
N2 gas. Okay.
combining with oxygen gas to make specifically 2 moles of
NO2.
NO2 gas. Now you
Okay.
got to pay very
Yeah.
special attention, guys, to make
There it
sure
is.
that the phases are there
About halfway down the table, and the mole coefficients are there.
and the mole coefficients are there.
I almost chose the wrong one because I did N2 gas plus O2 gas. It was 1-to-1 mole ratio.
Ah.
This problem is 1 mole N2 plus 2 moles O2.
Now I didn't double anything.
No.
It's literally a different reaction.
Right underneath the first one. So if you guys, your eyes all googly crossed, you might go with the wrong answer.
Right. All right. So you found the reaction, right? What was the delta H value you find on the chart?
Positive, and they show the sign 66.4.
Very good. Now I already know from the previous learning, a positive delta H is endothermic.
And just like a little mini sketch.
Okay. Start low,
Go
finish
high.
high.
Yeah.
That's what an endothermic graph looks like. Very good. Now we have another one we have to find. I see 1 mole of nitrogen gas combining with 3 moles
H2.
to form 2 moles of ammonia gas.
I found it.
Do your coefficients all match up?
1 mole N2 gas, 3 moles. Yes, I found the right
All right.
equation.
Is it written in the same direction as you found it?
It is. But what is different is it's not a positive sign.
Okay.
It's a negative sign.
Okay.
So that's the only thing that's different between these two examples, the sign on my delta H.
Right. Well, the number is different, of
Well,
course.
yeah,
but-
naturally
but-
a different reaction.
But everything else is lined up exactly. So if I have a negative, I am exothermic, and that means I started high and lost energy. Heat is exiting the system. That's the one we can always like kind of rationalize in our head. So if we can do that, we can default to what endo is. Now this next one, this one looks a lot like the one we just did, doesn't it?
No, it doesn't. The one we just did started with N2 gas and added 3 H2 gases to it to make 2 NH3.
But I see N2 gas and 3H2 and
But
2
mister,
NH2.
they're all in a different order. They're on the different side of the arrows. It's not the same reaction.
Ah, it is a reverse reaction.
Wait a minute. So you mean that I can take what I just had done and run it backwards?
Right, let's do that on number 2. Let's put a big arrow to the left underneath it, because that's,
Like that?
oh, no, I'm sorry, arrow to the right, my bad. Because it's going to the right, right? I'm taking those two things, and I'm a synthesis reaction making that ammonia.
Oh, and look at here. There's ammonia, 200 C. It's a decomposition.
There you
now.
go. So now
If the synthesis released energy,
it's almost like the arrow's going the other way.
the decomposition should absorb energy.
There you go. So all we do is flip the sign.
arrow, flip the sign.
Flip the sign. So it'll still be 91.8.
91.8.
But now it'll be endothermic. And I got to have a little different graph. There you go.
Mirror image of the one that it was before.
Right. I just started at a different spot and went reverse. So now we got to do some practice.
Yeah,
You think we got to look some of these things up and get good at this and make sure we can do the little nuances? Oh, you bet.
Yep.
So make sure you can figure out if it's exo or endo. And then how do we change it if we change a parameter based on the table? If we double it,
Half it, flip it. That's all you got. Double, half, and flip.
Those are the only 3 games we can play.
Double, half, flip. That's
really
the only
it.
we're going to do to you.
That's, well, that's it. So
All right.
that's it. See ya.